why is it plus? Why is it 1 plus function?
1 plus function.
Yeah, why is it?
Oh, because we're rotating around x equals minus 1.
Mhm.
So when we're taking the outer radius, it's the distance between x equals minus 1 and this curve here. So that's going to be 1 to get over to the y-axis, and then the square root of y to get over to this curve.
When you have like a minus stuff.
Essentially,
This minus here?
No, I mean like no.
I'm saying you should have like radical y
Radical,
minus
radical
negative
y minus negative 1?
Yeah.
Yeah.
Okay.
More questions? Is this concept giving people difficulty? Volumes of rotations, of solids of rotation? Yes?
I have a question. 6.2, number 4.
Okay. So once again, we'll draw a picture. We're looking at the region bounded by y equals ln x, y equals 1, y equals 2, and x equals 0. And we're rotating it about the line, the y-axis, which is the same as saying the line x equals 0. So, drawing this region, we have 1 is here, ln looks like this, y equals 1 looks like this, y equals 2 looks like that, x equals 0 is just the y-axis, so we have this region, and we're rotating it around the y-axis, so we can simply integrate over y. We're going to have pi volume is equal to pi times integral of just this radius here squared. The radius is e to the y. And we're integrating from y equals 1 to y equals 2. So that's equal to pi times integral from 1 to 2 of e to the 2y dy. And now we do a u substitution. Let u equal 2y. So du is equal to 2 dy. So that in particular we have dy is equal to 1/2 du. And when y is equal to 1, we have that u is equal to 2. And when y is equal to 2, we have that u is equal to 4. So that this integral becomes pi times integral from 2 to 4 of e to the u times 1/2 du. Taking the 1/2 out, we have pi over 2, integral from 2 to 4 of e to the u du. The integral of e to the u is just e to the u, so this is pi over 2 times e to the 4 minus e squared. Further questions? y is equal to ln of x, then x is equal to e to the y. Probably should have figured that out. Right. This distance here in terms of y is just e to the y. Yeah?
Can you come here and see if this one's relevant? Because I put pi b. My answer was this. That's the same thing as that, right?
Yep.
Right?
Yeah.
You have to write units cubed.
Sorry, what?
You have to write units cubed in there.
Units cubed?
Yeah.
Well, if they give you units, then yes, but in general, I mean, unless it's a word problem, they probably won't give you units. So, just know that if this was, if we're measuring units here, this one, if I said this is 1 meter, then this answer would be meters cubed. But no, when you're taking quizzes, don't put units. This is a word problem. More questions? So let's do exercises that are on your homework. You guys have your homework assignment? Yeah, this week's or next week's, whatever you want. Yeah, see, but I don't think I want you to leave early when I'm being videotaped.
Could you do number 9 actually, from 6 and 2?
Number 9? Sure.
Yeah.
So we want to find the volume of the solid of revolution given by rotating the region bounded by y equals root of x and y equals x around the line y equals -1, I think. Yeah?
Do y equals 1.
Y equals 1, of course. So once again, we draw a graph. Y equals x. Looks like this. Y equals square root of x. Looks like that. So we want to take this region and rotate it around y equals 1. So we're going to get volume is equal to pi times, and now since our axis is parallel to the x-axis, we want to integrate over x. So this is integral from, and this point here is 1, well it's 1, 1, because 1 is equal to square root of 1 and 1 is equal to 1. So we have pi times integral from 0 to 1 of the outer radius looks like this. So that's just 1 minus, or we can do it this way where we say the distance is just one minus root x squared. No, the outer radius is x, so this is 1 minus x squared minus 1 minus root x squared. dx. Okay. And to solve this, we have, this is pi integral from 0 to 1, and we FOIL this out, we get 1 minus 2x plus x squared minus 1 minus 2 root x plus x. And then distributing this negative sign and combining like terms, this is equal to pi. That's integral from 0 to 1. Here we have a 1 minus 1, so that goes away. Here we have a minus 2x plus x. So we get x squared minus x plus 2 root x dx. Is that correct?
Why do you have minus x?
Because I have a minus 2x. Oh, minus 3x. Yeah. Okay. So this is equal to pi. Well, we can integrate this. This is 1/3 x cubed minus 3 halves x squared. So this is the 1/2, so we need the 3 halves over here, and then we multiply by 2/3 out here, so we get plus 4/3 x to the 3 halves. This is from 0 to 1. The 0 doesn't matter because we just get zeros in every term. And for the 1s, we just get 1s in every term, so this is pi times 1/3 minus 3 halves plus 4/3. Which is pi times 5/3 minus 3 halves. Pi times 10/6 minus 9/6, which is pi over 6. And if you had this problem on a quiz, I would want an answer something like this. A rational number times pi. Don't give an approximation, don't leave it in decimal notation. Just something like this. More questions? Yes?
If y was equal to -1, the outer radius would be 1 x the square root of x plus 1, and the inner radius would be 1 plus x, right?
We would have the outer radius is like that, so it would be 1 plus square root of x, and the inner radius would be 1 plus x. Yes.
So what's under it, you add it if it's above it.
Yeah. Basically, I mean, you could come up with a formula that like tells you what distance is, but it's easier to just draw the picture, identify what's the outer one, and identify what the radii are.
Well, you could like try and not do at all the the graph, and if your volume is negative, then you know you got the wrong radius.
Yeah, and then you know you've switched your inner and outer radius.
So you just try again.
Yeah, but there's
So
you're likely to get confused if you don't draw the graph because you'll say, well, what is the inner radius and outer radius? Like, what is the distance between y equals -1? Or if they give you an axis that's not like perpendicular to the x-axis or the y-axis, that would be more difficult. More questions? Somebody have the assignment sheet? Oh, looks like I do. No?
this
one?
When I think it was 31 or something, and then touch with it. I think the one we did last time.
Okay.
You have to know that.
I don't think you're in the
No, what?
Every time. He's asking, we have to know that.
Yeah. Yes, you need to know how to find volume. Sorry, I'll make it easier, a little simpler this time. mean, the problem with a problem like this is that, I mean, it's so simple with just knowing the geometric formula that you're tempted to just use that and not use calculus at all. So here's what I'll do. I'll draw my axes. Now I'm going to draw my tetrahedron upside down. So I'm going to put the base at the top. And this is a 3, 4, 5 triangle. And these are all perpendicular. That's perpendicular. So it looks like this. And then this is 3, 4, 5. No, sorry, this length here is 5. So that this length here is also 5 because it's a 3, 4, 5 triangle. And then I say
This is the base of the equilateral.
the base is equal. I thought the base was a 3, 4, 5.
Oh, no, never mind. I was looking at the wrong one. Never mind.
Can you,
All right.
which number was it again?
No, I was doing 30.
Okay, but which number is it?
31.
31. Okay. So now, once again, we take some region located at Z. This is the Z-axis, this is the Y-axis, this is the X-axis. So at some particular Z, and for some little length dz, we ask what is the volume of this slice? That we just kind of take out of here. So the volume is going to be, since this is a right angle, we call this, say, f of z and g of z. Then we have the infinitesimal volume is equal to 1/2 g of z and f of z times dz, right? So it's just saying that the area of this triangle is 1/2 base times height, and then the volume of this little sliver is the area times the little height.